right, so we're going to talk about exact numbers and how that kind of leads into significant figures. So what you want to keep in mind is that some things are exact, which means they have no uncertainty. So like if I put some M&Ms in front of you and you count the M&Ms, there's no uncertainty. There's not going to be like 4.5 or 4.37 or anything like that. So what you have to keep in mind is, when am I using an exact number and when am I using a measurement? Because measurements are what have significant figures. Exact numbers don't. So just some examples of some exact numbers are like things that you can actually have. So like 6 students, I'm not going to have 4.78 students. Like, you're going to have whole numbers. Trees, you're going to have like, I have a tree in my backyard. So things that you can concretely just see have you're not going to have uncertainty. So these basically have like infinity sig figs, and they won't affect anything that you're doing with sig figs. Another big thing that has no uncertainty are conversion factors. So it's been determined that without a shadow of a doubt, 1 liter is exactly 1,000 milliliters. So if I'm doing a conversion factor with this, that does not affect my sig figs. If I'm going from inches to centimeters, that's an exact conversion. So again, this is not going to limit my sig figs. Typically, when you're doing a conversion factors or you're doing a conversion, typically what you do is what you start with. So if I have 4 significant figures to start with, that's typically what I'm going to end with. And that's what you kind of have to get used to, because from here on out, you need to have the right number of sig figs. Part of the significant figures is the measurements, and you have to be able to take correct measurements since chemistry is such a quantitative area. So you want to make sure that you always estimate one place further than is marked. So again, if it goes out to the singles, like 1, 2, 3, then you would want to estimate to the tens. If it goes out to the tens, you would want to estimate to the hundreds. That last number is always assumed to be an estimate when you're doing it. So if you don't do it or you leave it out, you're not telling us the whole story. If you overestimate and just make up numbers, now you're just lying. So really what we're talking about with sig figs is basically, how do you measure appropriately and how do you show people that you're measuring to the best of your ability. So this isn't in your notes, this next slide, but basically we just have 3 pictures here of 3 different graduated cylinders. And you really have to be careful with graduated cylinders because they have different sig figs. So this first one over here on the left, we can see our liquid here, and we can see that each of these is a single digit. So like we have 31, we have 32, we go to 33. So we're stuck between 32 and 33. We don't know where exactly, and that's where that estimation comes from. So we know definitely we have 32 something, but again, we don't know what it is. So we're going to write 32 point, and then your estimation is that last one. So I don't know, I think it looks like 32.6. So I would write 32.6 milliliters. And these first 2 numbers are definites. We know them definitely. This last one's our estimate. They're all significant. So this number right here has 3 significant figures. If we're looking over here at this next one, now we go out a little further. So we have, now we're at 8, and now we're going to 10. So we have 8.1, 8.2, 8.3, 8.4, and we're stuck between 8.4 and 8.5. So we know definitely 8.4. And then again, that last thing is your call. You may not agree with me. Like, I'm going to say 8.45. And again, you may say you're crazy, and that's okay. But that's where that estimation is. And again, it's always assumed that this last one is the estimate, so that's why you want to include it. The last one right here, we're going by singles again. So we have 30, 31, 32, 33. We're in between 33 and 34, so I'm going to say 33.6. One more thing you have to be really careful of with graduated cylinders is if you get it exactly on, that you can kind of estimate a little bit further. So just be very careful of what you exactly know. Like if I'm exactly on 8, I'm going to say that I definitely know it's 8.00. If I'm exactly on 30 here, I know it's exactly 30.0. Just make sure you do that for these. When we do sig figs, just keep in mind, I mean, they're not that hard. You're just kind of getting used to them. But again, you have to remember, significant figures come into play when you are measuring. So if it's a measurement, then you have to do sig figs. So like your lab today, they're all measurements. You're going to have to do sig figs. So basically any number that's not a 0, let me just move that a little bit, is significant. So if we have 456, we have 3 sig figs that we care about. If we put zeros in between other numbers, so like we have 709, we know the 7 is significant, we know the 9 is significant, and by association, that 0 becomes significant. So 709 also has 3 sig figs. From here on out, it gets a little tricky with zeros. Zeros are typically the thing you like least about sig figs. When we write big decimals, so we write 0.00057, what happens is the lead in zeros, the zeros in front, don't actually have any significance because they're not actually telling us a measurement. They're a placeholder. They're trying to show us how small it is, but it's not an actual measurement of the number. And this is actually means we have 2 sig figs. The best way I can show you or explain it to you is if we wrote this number in scientific notation. We would write 5.7 times 10 to the negative, ooh, that went down, 1, 2, 3, 4, 5, so negative 5. And what happens is if we do it like that, and I move this so you can actually read it, you'll notice that none of those zeros are there. So it's not part of the actual measurement, so it's not actually a significant number. And you have to get a little used to that. Zeros in the front don't matter. Zeros at the end can matter. Zeros in the middle do matter. So it's fun. I know. If you have zeros at the end and it's to the right of the decimal point, so for example, you measure something and you get 46.70 grams. We know the 46.7 is definitely significant. That 0 is that estimate, and that does matter. That's what the scale estimated, or that's it's exactly on the line of your ruler or whatever. So if it's at the end after a decimal, is important because what it's doing is it's that last estimation that you're taking. So this guy right here is 4 sig figs. And our last one, if you have zeros, they're at the end, but there's no decimal, then it gets a little nastier. So if we write 4,500, we have 2 sig figs. It's the same kind of thing as this rule up here with the zeros out front. Zeros at the end, if you're just saying, oh, I have 4,500, it's almost like an estimate. So they're almost placeholders. If I take the time and write 4,500 dot, now you're saying this is an exact number, and now you magically have 4 sig figs. So I know you've done this in 9th grade. You need to remember it. You need to take some time and pay attention to when is it what. Like I said, tomorrow you'll get to ask some questions if you have any want it. But you just want to make sure that you're working on this. All right, so we're going to do a couple practice problems, a little bit of math, and then we are all done. All right, so we're just saying how many sig figs each of these are. So hopefully you can scream them out in class, and we'll all be very excited about it. So number 1 has, magically, 3. Number 2 has 2. Number 3 has 4. Number 4 has, I know you're on the edge of your seat, 1. And last but not least, number 5 has a lovely 5. So again, you just want to make sure you're checking those and practicing them.